gonna get to my whole I still have very little idea of how to do love heart. So I need to wait. So this is if in doubt, draw a bigger diagram. So dash.
Okay, so we're gonna go through this 2016 question 8. Okay.
Which one was that?
So that was the one where it was like Anne always goes first.
Yeah. Okay.
Gets 1, and then Bob gets 2.
Okay, so we didn't finish that question.
Yeah. Gets 3, and then Bob gets 4, and then until there's none left, not enough, and then they just get the rest. Whoever's got that last move.
So they always have the same.
Yeah. So whatever this n is, it can be broken up into sort of.
So whatever the n solution, we choose 2n as this actual solution, right? And we're trying to find it up to 500. Basically.
Yeah. So we want one that can be split into half like this.
Yeah.
And half of it can be split into half, right?
Yeah, so we find an n between 0 and 500 and double it for our solution. The maximum solution in n 0 to 500.
Yeah, so we're looking for the maximum n less than 1,000. Yeah?
Less than pretty much 500, because like then we doubled it for the solution, actual solution, when we're finding it.
Yeah, but how do you know that the doubling also satisfies that property?
Oh, because halving it solves that property. For doubling, no, or maybe times by 4. Doesn't matter.
Yeah, so I'm gonna grab. Oh, you can sit in the.
I like to.
Oh, okay, cool.
Can I sit on the floor?
I don't want to sit.
Okay, I sit on the floor.
Is the chair not comfortable?
This floor's better because it's made out of carpet. It either has to be 2 more than an odd triangle number.
Didn't we do this last week?
Yes.
You here?
I was here, but like,
Yeah.
but like, I didn't figure out. I went home and did a bit of it.
Oh, okay.
So it's basically either 2 more of an odd triangle number.
Yeah, I guess the thing I'm interested in. Do I have this? Yeah. This is kind of like my work tonight. So the question was, you have some number n, right? You you have a number n, okay, and then so like you have like n sweets or something, right? And then Bob and Ann, so A and B, right? Ann goes first, and you keep grabbing sweets. So Ann takes 1, then Bob gets 2, and then Ann gets 3, Bob gets 4, and you keep doing this until there's not enough for the last step, and that last person gets the rest.
Yeah.
Okay. And so if you keep doing this, they're saying that this n has to be able to be splittable in 2 piles, equal piles, right? So you keep doing it, and you'll eventually get 2 piles of the same, okay? And then it says, if you actually halve it, you can also do the same with each pile. So you can actually quarter it, okay? The question itself actually only said that if you take half and half, and you do the same process to both piles, and we'll end up with the same as Bob, right? So that's not the same as saying that they end up with the same in each of the smaller piles, right? But they have to because they do the same process on each one. Yeah. Okay. So whatever property makes n splittable into 2 this way has to also be possessed by a half of n. Yeah. Okay. So I thought one thing that was really interesting, which is like not usual, is like we had someone in the audience on YouTube give us a key idea, right? So basically, you know, if Bob, you know, who goes with all the even numbers,
Oh.
Sorry.
you know, so if Bob gets the second last pick, right, then all the sum of the even numbers up to that point will be sort of half of the number, right? So, and since it's just the sum of the even numbers, the person made an observation that that's twice the triangular number, right?
Yes.
So there's 2 outside of 1 plus 2 plus 3, so on, right?
Yeah.
And since that's half of the number, then the number is 4 times the triangular number, okay? So that's one possibility. The other possibility is that Ann gets the second last pick. And so it's the sum of the first so many odd numbers, which is a square number, right? So then the number is either twice a square number or 4 times a triangular. Okay.
But perhaps we can also view them together.
And I'm pretty sure like you show that like and can't be the second one.
Oh, and then can't be the second last.
Yeah, because if and's wait, hang on.
Wait,
yeah, I guess that comes out in the end just because there's so few squares.
Okay. Yeah.
But
That might be.
yeah. So maybe we kind of see if you look at so the point is there's not very many squares and there's not many triangular numbers less than 1,000, right?
Yes.
And you know, and if this is, and you're trying to look for the biggest n that this works for, so so you know, for example, one of the things I did, I just listed some triangular numbers, right? So the first triangular number, what do you have? Like 1, and 1 plus 2 is 3,
6.
plus 3 is 6, and plus 4 is 10, plus 5 is 15, 6 is 21, and so on, right? You know, you could have different ideas, but this is a good way to follow on from that idea, which was kind of interesting. So 45, 55.
Also today, can we have
66.
can we have some like proof questions done so we can?
Yeah, so that's what we got. The 2000, we got 9 and 10 as well.
I need more structure and proof.
Yeah, because I don't know how.
I mean, don't worry too much about the proof. Like you got to get the idea. That's the main thing, right? I mean,
But the problem is I don't get the idea.
Yeah. So then don't worry about the proof. Yeah, that's kind of what I'm saying. 105, 120. Okay, it looks like there's a lot, but I mean, they start running out pretty fast. Because you only have to go up to 250, right? Because this is 4 times the triangular number. So to get it less than 1,000, you only need to get it to like 250. $136, $153, $171, $190. Believe it or not, actually copying what I wrote down before is saving me some brain power.
What, really?
I don't know if it is though, that's the thing.
210.
210s, next one.
Oh, yeah.
Yeah, 210.
231.
You only need to go up to 2.
Yeah.
Next one's over 250.
Yeah.
So it's 253, so it's too big.
What is 66 and 90? Let's continue. Continue. Oh.
Yeah.
So you're looking for stuff that like appears.
So like if we assume that so Bob ends up with the second last pick,
Yeah.
then it's gonna be four times one of these numbers, right?
And the other one's going to be.
Yeah, and then the number itself it could be double a square or it could be 4 times another triangle. Yeah.
105 and yeah. So 105.
Okay, so can you see that? So for example, if it's 4 times this number, right? And so then 2 times this number, then
The 2 times this number has also
so yeah, if it's
also
4
has
times
to be
one of these
4
numbers, then 2 times this number has to be like a square,
Wait, 2 times.
or it has to be 4 times another triangular number. So that's like saying half of it is a triangular number.
Yeah.
Yeah. So
You can't have an odd number here.
so if you look at so you have to have even numbers, yeah, because they have to be.
Yeah, so cross out all the odd numbers.
Well, no, they could be odd squares, right?
Yeah.
So if it was another triangular number, can you see that? So it has to even, and then can you see that half of that is another triangular number?
Yeah.
So that satisfies the property.
So
Yeah.
it can't be since none of those there are square. I'm pretty sure it can't be a square.
Oh no, because 4 times this is the number. So 2 times this has to be a square. So you're checking that.
420 is on the square.
Yeah, I know. I'm just saying you're checking that 2 times this is a square, not 4 times this.
Yeah, but none of these are. Wait, not 4 times. It is 4 times, isn't it?
Wait, is it 4 times? So yeah, okay. So 4 times this is the whole number, right?
Yep. Yeah.
Oh, okay. And then that
Half of that.
half of that is 2 times this, right?
Yeah.
Okay, so it is equal to a square then.
Yeah.
It has to equal to a square.
Yeah, but since none of them are, then we know that's not.
Yeah.
Yeah.
So then it's if I do that like.
Yeah. So none of them are squares, good, except for 36. Yeah.
So that means like.
Which is way too small.
That means that Anne would have picked class from both.
Yeah. So 36 is a square, by the way.
Oh.
Because if Anne picked third.
And 1, I guess.
Why is
Yeah.
36 the last one?
Huh?
Why is 36 the last one?
Like 36 is square.
Huh?
It's square.
Yeah, but like, why is it like the only square? Is it the only square?
Like 1 and 3 third. 1 and 36 now.
Oh, I don't know why, but we just listed them right now. So
Wait, can we use arithmetic progressions to solve the problem? Was that not necessary?
Do you have to say this?
Because like,
well,
I
you
feel
don't.
like
I mean, I'm just going by the suggestion.
Oh, so
And the thing is, like, the point was when the person said the suggestion, it wasn't clear that it solved it when it actually is really clear that it was solved from the suggestion. So this is what I'm trying to basically clarify. Like, I'm trying to show you explicitly that it actually does solve it. So, okay, so I mean, this is really promising already. So let's try it. Yeah, so 210 and 105. Yeah.
Yeah. So 840.
So 840 is a good candidate for the answer.
Yeah.
Okay.
because if you split it on 420,
Because 210 is a triangular number, right?
Yeah.
And 10
And-
is a
And half of it's also a triangular number.
Now you're only looking for so that since that's all the like these ones exhausted, then you're only looking for the twice the square ones. So
Yeah.
that means you're only looking for square numbers between 420 and 500.
Yeah. So there's
So
not
then
very
which one?
many. There's like 20.
There's like
There's like 3 squares.
They're like 441 and like 484.
That's it.
Yeah. And 441.
484, and then you just test those pretty sure.
Yeah.
You're fine.
And then you just test them. Yeah.
Yeah.
Okay. And then I think, if you were really worried, you could also actually explicitly see how they're sharing,
Yeah.
right? So if it was 840,
So
right?
you just see which triangle number that is.
Yeah, this is 210.
For example, they share the 840, you get which triangle number?
210 is the 20th triangle
Wait.
Yeah.
So
that means-
840, we find the closest triangle number
number.
less
So you
than
would add all the
840.
way to 40 and then add something. That's why.
No, all we have to do is find the
40, and then it's 1,
Yeah.
3,
Something 39.
39, and then
and then
the
this one
rest,
would be
and the thing has
this
to be
one.
less than 40.
Yes, it's
1,
20.
yeah.
It's 20.
Yeah.
Yep.
Okay, good.
Oh, because what I did was like I understand like given if both people
Yeah, so
did
20,
n
that
times-
works.
if both people took the stuff n times, then the last then Anne's turn must take n. So that's just half. Of
Yeah,
it.
because like
Oh,
each
okay.
time he's taking one more, so like
So that works, right?
yes.
Yeah.
So
And then if you halve it, it's 420, right?
yes, it still works. 'Cause-
And then 420, does 420 work?
yeah,
Well,
because
you just look
it's
at the
210.
Yeah.
Half of it is 210.
So what's 105?
So it has
It's
105.
14. It's 14.
Just 2, 4, 6, 8, 10.
14. Wait. Yeah.
14?
Yeah.
Yeah.
Okay.
Yeah, 105. That adds up to 1.
And then you said it's 7, is that right?
Yeah,
So yeah,
that's the
Yeah.
biggest solution.
and then you just the other two, I guess.
Yeah, so you check that like, was it 880 something, yeah. Okay. Do you want to check it or do you want
Checking might be good. Yeah.
to? Okay, so bigger than 840, we need something that's 2 times the square, yeah?
2 times the square. Yeah.
2 times the square. Well,
So 20 squared is 400, yeah?
Oh, and I think we can like check it really like easily because it has to be 2 times the square in itself, and so does the
The one below it? Is that
like
the same?
okay, the one below can't be 2 times the square. Yeah.
Mm-hmm.
So that means like the one
Yeah.
below has to be like one of those. So you can just quickly check that.
Oh, okay. So the one below it, so the square has to be 4 times the triangular number. What are you saying?
The square has to be 4 times. I think so. Yeah. Wait. No. Wait. So because just given like the numbers like 2n squared,
Mm-hmm.
and then
Yeah. So n squared can't be like 2n squared. Yeah.
Yeah.
Yeah. So
Is that
then
what
n
makes-
squared has to be 4 times the triangular number. Then.
yeah,
which is not possible under the circumstances.
n squared is 4 times the triangular number. So like
That doesn't seem to work.
yeah, then since you only have checking 21 and 22, if you check 21 squared definitely is odd. 21 squared is odd, so it doesn't work.
Okay.
So 22 squared is 484,
That's the last one.
which is like if you like divide by
So it's 4 times 121. Yeah.
and then 121 not on the best.
Yeah.
Yeah, so you know.
Okay. Cool. Yeah, that's one way to do it. Excellent.
That's it. Just probably from like a guy who's done it and like I don't know, and then just like it sends like the answer that they did in like that year.
Yeah. I think, I mean, there's lots of ways to do it, but I mean, it depends on what your observations are, right?
Yeah.
And this is your first observation, fine.
And yeah,
And I mean, this would be a great time to do question 8 because it took like 10 minutes.
yeah.
Oh yeah, I should have handed out some notes. Some notes.
Oh, notes. Nice. Nice.
Wait, so figure out who's gonna. Which one?
Okay. This way is incredibly
How about-
sketchy. Like no one's
How
going to.
about who picks the eggs? Okay.
Yeah. So Oh, obviously, within the week of this exam, the most important thing is sleep. Yeah. Like
Yeah,
it's
yeah.
getting-
Yeah, which I will
you gotta catch
I will be
up on it.
unfortunately forgoing.
I mean, these notes they're not for you to like. They're not for you to read and finish all the problems before the exam. Okay, they're just there because like it's sort of a summary of what we've done, so you
I
kind of
have
know.
0 sleep every day.
Yeah.
That's
So-
not
Let's make it non-zero,
yeah.
and then
Wait, what's the good? If it's 6 hour good,
no, it's not. And you gotta erase. You can't erase the debt just the night before. You have
Yeah.
to like.
I just
Well,
do 10 every day.
So basically, you should probably just go sleep now.
Yeah, it's like, just do 10 every day until like Sunday and then
I actually have to wake up at like 2 o'clock and 4 o'clock.
7 should be.
Why?
I have to go swimming
Swimming
in the morning.
Because isn't it cold?
Yeah, no, it's indoors. It's all good.
in the morning.
I got every
Yeah, it's one of those people. Like we got like I know a few people who do that, like two. So there's two people in my group who are like pretty good at swimming. And then like wake up like 4 in the morning to go like one of them like wakes up 4 and goes swimming every single day.
every day.
Yeah.
That's pretty good. I only go once a week.
Okay, so another one we want to go through.
Also Thursday night. I see Thursday night.
So the other one that was on the list was question 10. Okay. From 2016. Question 10.
Is it just the black white dots?
Yeah, have you done this one?
Yeah.
So the question goes like this. You have a circle, right? And you have these black and white dots that are alternating.
Yeah, is this?
Okay.
This represents the 12 notes.
And you let n be greater than 3.
Yes.
And you put the numbers minus n, minus n minus 1. So minus n all the way up to 0,
Yeah, then to
and
plus
1, 2, all the way to n, right? You put one of these numbers at each one of these points, and then so you can see there's 2n plus 1 numbers here, right?
Yes.
And then there's 2n dots. So there's one number left over,
In the center.
and you put it in the middle, okay? So it's neither.
And then what's the answer?
Yeah, and then but there's some more rules, okay? So one of the rules is that
Any consecutive 3.
yeah, so like if you have a diameter like that, right? The diameter, so there's a constant s for which the diameter adds up to s. So this number plus this number plus that number equals s. Yeah, for all the diameters, it's the same s. Yeah. And then anytime you have a black, white, black on the outside,
Yeah.
it also has to add up to s. Okay, so it's all the diameters and all the black, white, blacks add up.
Oh, it's
to
like a Sudoku puzzle.
Wow, I thought you tried this problem. What? Haven't you tried this one? This is the one you suggested.
I haven't even read the question yet.
Huh?
I haven't even read the question.
Oh.
I didn't suggest that one, so I don't know. But anyways, it looks a bit like a Sudoku puzzle.
Sudoku was just simple.
So is it not the same for white, black, white?
Okay, so basically the question says prove that s equals 0, okay? And I guess the middle number, this number in the middle is 0.
So anytime you have a diameter, it's gonna equal to
And
the
then
black,
there's like
white,
an
black.
investigation.
Yeah.
Yeah, these only works. So it's not just only works. It actually works as it's like works if and only if n is even. Yeah. So that means basically if n is even it works, and if n is not even it does not work. Yeah.
So one thing is because that is so every diameter is equal to s, right?
Yeah.
So that means diameter is equal to the same thing. That means since the center doesn't change the total of S, like it doesn't affect how the the edge works. But so for the first observation, so every diameter has to equal S, and every black by black has to equal S. So every time there's a black diameter, so every time there's a black diameter, this has to equal this, right?
Sure.
What?
Also, can you speak a little bit more circle, right?
No, they don't.
So,
The other
these include the middle.
Oh, there's only thing for each and every. So they
Oh, why?
Oh, so that should it the label in the central point is 0 and this is 0? Does it have to be 0? Right, that's right.
So every time you have a white diameter, since it's 2 and a black has to connect to a black dot at the opposite end, right? Does it?
Oh, no. It could connect to a white dot.
Oh, okay.
I mean, the thing is, okay, so if you haven't tried the small case, if you haven't got any ideas,
Yeah.
try the small cases. And you'll see in the small cases, they definitely connect to white dots and black dots. And
Everything else in between.
No, I'm pretty sure it says black, white. Yeah. So white, black, white is the same.
yeah, so white, black, white doesn't have a condition, right?
Oh,
That's important, but
yes.
well, it's not necessarily important. I guess it's part of the problem.
0?
Yeah.
So black, white. Yeah, it does.
So they don't have to be. So they don't have to be spaced evenly, right?
But do you know how many points there are?
No, it's anything.
Do you
Anything.
know how many points?
Any odd number more than 3.
There's 2 endpoints.
2 endpoints. So if you have this point, if you have a small case, then these two are equal to.
I like how this the IMO reference is like more hidden now.
Yeah, put it in the notes.
Yeah, but I remember the questions how I remember.
Yeah, I guess
Yeah.
psychologically.
See, for a small case, for a small case of n equals 5, well then you have.
n equals 5 is not small, okay? n equals 3 is small, see?
Oh, what?
More like,
But you can't have the black by black on the outside. N equals 3. So like, you have to keep that condition.
I guess it's impossible for it to work for n equals 3 if this is true.
Works. What do you mean works? There is no arrangement if n is odd.
Yeah.
well,
So for example, if n is 5, no, if n is like, no, I mean, with n is 3, how many dots there are? Well, there's 7 dots. This 7 dots. Yeah. So there's no.
Yeah, so basically, like, if you don't have any ideas straight away, you just try all the small case, yeah?
does 3 not work?
3 doesn't work.
Does it work?
It's a little bit hard to consider right away. I mean, it doesn't work because,
Wait, can you see the
but I guess it's easier to check that it doesn't work after you know the middle has to be 0 and they have to add up to 0.
Well, oh, okay.
If you guys haven't had a go at this problem before,
Yeah. The numbers all add up to 0. So that means they have to. S has to be 0, doesn't it? All the numbers add up to 0.
I mean, it does have to end up being 0, but that's, I guess. I mean, that helps in your reason, yeah.
Can we prove it by contradiction? Say S is not 0.
Hmm.
How about try and prove it with a mix of contradiction and induction?
Yeah, see, this is the problem when you know methods of proof. That you're trying to select your method of proof, but really you
Yeah.
have to have just an idea of
Oh, okay.
why this problem
Find
works.
an idea and then base your proof around the idea.
Oh, yeah, so don't try to think about.
I mean,
How-
sometimes the method really solves the problem because there's only one way to
Yeah.
carry out that method for that problem,
Yeah.
obviously, and it works.
But like, I don't know when that happens.
But like, we're not trying to get so bogged down in the proving that we don't know the ideas.
Oh, this question isn't really that hard. Pretty sure.
That one, yeah.
Yeah.
But it's a nice kind of question for that kind of
Right.
moment.
Because it's just like all numbers are not 2 more 3.
Yeah.
Yeah. You give 2 more 3 can't be right.
And you just got to do it. So basically, if you do the examples, it doesn't concern you guys yet. It's in the notes.
Yeah, well, which one next?
It's question 10 in the first set. There's 6 sets of problems in the notes. A lot of them we've already done. No. So I already said this. So we don't try to do them all. I'm just giving you for a reference, yeah. And maybe we can work on it next time as well. So the most important thing this week is just to sleep. Okay.
I still don't know.
Go to sleep. Have a micro sleep right now.
Very
That's
impossible.
not very good.
It's gonna be very impossible for me when we got exams all the time. It's like Tuesday, Wednesday.
Yeah, I mean,
Why? Because they don't care about AM and P. That's why. Just care about whether you can write 1,000-word essays on wider.
Versus round.
No. No, more boring
well,
than that.
I think. See, the thing is, I think
wider-
people would care if they understood to care.
My goal is
Yeah.
to finish this.
If you don't know it, no, don't do it.
Wait.
Don't do that.
Wait, is it the fact? Is it the fact that they're all consecutive numbers matter?
Probably. The fact that
Yeah.
they tell you that most likely means it wouldn't matter.
If it puts example set,
Close.
it's surely
Let's-
similar sheet in like training class.
I had like last year's notes.
Yeah, last year's online.
This year, I just kind of made it look a bit more friendly to younger people.
So well, if you had n equals 4, the small case, the middle number be 0.
I was gonna consider using this, like using a few questions like before the exam to warm up. But then I realized I could probably just use it with questions 1 to 4 in the actual exam to warm up.
Yeah.
-1.
I have to think how much I'm actually gonna study for my other exam. It's,
Priorities.
So even with a small case, it's really hard to actually find something that works. You have just a
okay,
case.
now that I think about it, I'm wondering why this is actually in the Aimo. Because I remember I think like in around year 8 or something, I searched up like Aimo questions. I think this one like came up, and then like I looked at the solution, some solutions someone posted, but for some reason like I couldn't understand it. Like I wasn't sure what they were saying, so then I just gave up on it. But like now look at it, it's not that bad. This question is
Yeah.
Question 8's like the largest integer with the digit sum 18. Digit sum 18 and
2 times the 3 digits on 27. That one seems.
That was I switched it out with the investigation
Oh,
because that the one of them was for smallest and the other one was for largest.
oh, okay.
Yeah. But the question I used in the exam. So
Like for question A in this one, like can it be like as many like decimals as you want? For question A in this one, like, can it be as many different?
oh, you're not even doing this question anymore. All right, I'm gonna have to move on here. Okay, so
Can you explain it for me?
all right, fine. So you notice all these numbers add up to 0, right?
Yeah.
So that's gonna be important. I mean, one of the things you could do is you just add up all the diameters, right?
Yeah. That equals 0.
So if you add up all the diameters, of course, I try some more cases and try to draw things around n equals 3 and 4 first, but
that
I did this a long time ago, so I'm gonna skip that and
So
then
if we
say add
all
up the diameters. Okay, can you see that the diameters add up? There's n diameters, right? So there's n, and each of them add up to s, right?
Yes.
So it's ns equals. Okay, but what's on the diameter, right? If you look at all the diameters, that'll get all the points except for the middle point. Yeah. And you'll get the middle point like a ton of times, right? So you get all the points plus, so all the outside points plus n times the middle point, yeah?
Yeah.
So that's like all the points plus n minus 1 times the middle point.
Yeah, and put that up to 0.
Yeah, so we can call this middle
So
number
all the
x.
points is 0. So all the points is 0.
Call that x.
So
And then so this
because
is,
all the points is 0, so this
Yeah.
it's just going to be minus n minus 1x.
just minus n minus 1x
It's
plus. It's n minus 1x.
n minus 1x plus 0. Yeah.
Yeah?
Oh yeah. You
And
counted
we get
all.
the co-prime thing.
Yeah, so can you see how to proceed from here?
Oh, so n times s equals n minus 1.
So S and 3 digits.
Oh, is it obvious that s has to equal x?
Wait. No, that's
There's a few possibilities.
So
There's -1 as well. That could quickly work.
so if you add up diameters, what about the edge points? Black, white, black. We're not worrying about that right now.
Not yet. Just look at that first and see if you can like.
So add up diameters, that means ns has to be equal to n.
What could be significant about that equation of it? Like, think of like.
So like there will have to be integers.
Yes.
Oh, good, yeah.
So that means n and s must be
Wait, and then n minus 1 on co-prime. So.
yes, n and
Yeah.
minus 1 must not share a common factor because it can't.
Yeah. So if you look at the theory we've been doing, right?
Yeah.
N divides this.
X divides.
N divides this.
X
N does
divides
not
n.
divide n minus 1. That means n must divide x.
No. N divides this. It's not that n does not divide n minus. N minus 1 and n are co-prime.
Yeah.
Okay? Because this n's not prime.
Oh
necessarily,
yeah.
Okay? So n divides this, but it's co-prime with n
Co-prime.
minus 1. So it has to
else
divide
it
x.
uses- yes.
Right?
Yes,
Right?
n
And
is-
similarly, can you see?
X
that means
divides
you can replace x by some value.
Yeah, and similarly, n minus 1 divides
S.
s. Right?
Well, there's kind of a problem with that because if you replace s with n minus k times n minus 1, a times n minus 1, and you replace x with b times n, well, just end up with
Is 3 people watching?
what?
3 people is watching? Oh, now it's 2.
Every time you mention the audience, someone scares away.
Rah, no, there's only 1.
What really?
I'm kidding, there's 2.
So it's Quan and someone else. I think it's the same guy as Friday.
Oh,
Probably anyway. I don't know.
Wait, is it that that guy in the holiday bus? That guy came Wednesday.
No, I don't think so.
And is it someone who hit third now?
I don't know. Probably. We mentioned him and they left too.
What?
Oh no.
No, they
Oh,
don't.
he's back. Oh, guys, there's some obvious consequences. of this.
Yes.
Come on.
Because like if you replace each with a times the n minus one b times, then they cancel out.
Look, I think like for n to divide x, right?
Yes.
Like n's the biggest number here.
Yes. Because then x must be really big then. Oh, okay. So n x must be like really big, and that s must be bigger than n. Let's just say
X is either
must be really bigger than n.
Well, x is one of the numbers, by the way.
Yes. So like, how can it be bigger than n?
well,
So that means they have to be the same.
X has to be 0, 1, or
or there's one other possibility.
What are the possibilities?
0, 1.
0 and
Zero.
a negative.
Wait, negative n and n, right?
Yeah. Right? They're the only multiples of n.
Yeah, that's the only possible.
And what about s?
S, well, S can also equal zero.
N
Zero,
plus 1 and n minus 1. Negative n minus 1.
Yeah.
which cannot be exist because they're bigger than the range we provided.
Well, hold on. So s is
Zero can
Zero.
be zero.
with 0, yeah?
Negative n minus one.
Negative n minus 1, yeah?
Or 1 minus n.
Yeah.
Uh,
n minus
Oh,
1.
minus one.
N minus 1.
And why can't it be like 2n minus 2 or something?
Because
So
that's too big.
it's- N is larger than 2.
Do you think
Yeah.
I'll
N
actually
is
be?
equal to 1.
And can you see, like, when you put these values of x in here, it forces s to be one of these values, right?
Yes.
So 0 and 0 go together, right?
Yes.
Negative, negative should go together, yeah? You see that?
Yeah.
So basically, x and s are both 0, or they're both negative in those numbers, or they're both positive in those numbers, yeah?
Well, that will make sense because if S is negative, then the
Yeah.
X is negative, then the general connotation is that the S would be negative.
I mean, so if you do some small cases or something, I think, or like, I remember having this thought, but I don't know. So it was that to eliminate the possibilities, it would not be enough to just use the diameters anymore, okay?
Yes.
Because we use them pretty much.
We use them thoroughly.
But we haven't used the other rule, right?
Black, white, black has to be also equal to S.
Don't you put n in the center? You have to up to n minus 1.
Well, black,
Yeah,
white,
like let's pretend x is not 0, right?
Yeah.
And I'm sure the argument should probably work the same for minus n and n, yeah?
Yeah.
So like assume x is n, yeah? So n is in the middle, yeah?
So that's n the biggest number.
So not only is n in the middle, it has to add up to n minus 1, yeah?
Yeah.
Right?
Yeah, so that obviously it's a
It's not obvious.
it's not obvious, but this has to be a contradiction. If x is n, then s is n minus 1.
Hmm.
Well, then that means each diameter of the two ends has to equal minus 1.
No, so this will not give you a contradiction, right? Because the diameters will not give you a contradiction.
Yes.
You have to go on the circumference now.
So do we know that there has to be n is even?
No.
No, we don't. So if we have a diameter, then the circumference. Is also equal to s. So right now we're s equals n minus 1.
Yeah, so it has to add up to n minus 1. And the black, white, black has to add up to n minus 1, right?
So each black, white, black. I mean, it's kind of intuitive that it won't work.
No, I didn't think that makes sense.
Because you don't have that many big numbers.
Oh, there's
positive
three of them.
numbers.
Yeah, so think about it, okay? So look, you know, one of the ways to solve things is think about extremes, yeah?
Yes.
So like minus n has to be somewhere on the circle, right?
Oh yeah, minus n has to be somewhere on the circle, but then where? If it's situated on a black dot,
Or it doesn't matter if it's black or white, it's always gonna be in some
in a three.
Yeah.
In a three. That means if you add if you add the biggest numbers, n minus 2 and n minus 3,
Yeah, so if you have minus n and you have to add up to n minus 1, right?
yes.
So you basically have to add the two biggest numbers,
Yes.
but one of them's in the middle already, right?
Yeah.
Does that make sense?
So minus
So if you have minus n,
n, then you have to add up n and n minus 1. But
yeah, so for minus n to add up to n minus 1,
Two Edwards.
you have
you know,
Maybe
you need a equals n and b equals n minus 1.
but n
Or
is
the
already
other way
used,
around. Yeah?
used up already.
But
And
n's already in the middle.
so that means you can't.
Yeah, okay, so the same argument works for the other one, right? You just do minus n and n. So therefore, that's question 10 done, right?
Yeah.
I can give you a little bit of the investigation.
I mean, like, it's so easy once you know what's happening.
Yeah.
That's the problem.
But, you know, if you guys haven't really attempted this question, I might skip it.
Yeah, we'll skip it. So
But
let's go.
I think
Why
to
would-
start
wait.
this, you should try and see why it doesn't work for 3 and why it does work for 4. Okay.
So if you have 3, then that's just 7 dots, right? So we already proved that the S has to be 0.
Yeah. So now we know.
And
we know
X
is 0.
has to be.
Yes.
What is it? So the center has to be 0, and everything else have to have.
Yeah. So that's
Yeah.
actually the end of the problem, I think. And then yeah. So the opposite things have to be negatives of each other.
Yes.
And then these all add up to 0.
Well, let's think about extremes, okay? With n equals 3. So you have to have the biggest numbers, 3 and negative 3, on there somewhere.
Yeah.
Yes.
I think we'll do this another time because you guys haven't really caught up with this. It's not.
Is everyone coming on Wednesday?
Yeah.
Alright, so that's question 10. Maybe we can come back to the investigation. What about 2016 question 9? Does someone want to go through that? Maybe we can do that because that's one where like it's pure induction. Well,
Yeah, it's pure induction, which I'm not good at, but okay. I'll try and do something.
what was the problem? Can you just remind us of the problem?
So the problem is basically you have here, you have a triangle, right? And every triangle in this problem is right angled. It's given. Every triangle.
We can do the altitudes one next. Oh, yeah.
You have another triangle. And here's another distance. This is the same distance. So if you have this is x0, this is x1, this is x2, and so on. And this spiral continues all the way.
Okay, focus on your audience. We have to understand what you're saying. What are you saying?
Oh, okay, so and this is x3. So basically, what we're trying to.
There's a bin on this.
Oh wow, there's 3 people watching. 4 people.
Oh, really? As soon as you started talking, more people joined.
Yes, because I'm a host
No,
of
I-
Amazing
I-
Music.
no, I
Please
thought
subscribe to
something else.
Amazing Music.
All right.
Okay, so x.
I finished it.
So we're trying to
Do
prove
you still remember this question?
Yeah.
that
Because I
x0
did it, like, just then.
plus
okay,
x0
good.
squared plus x1
I just
squared
remember there was
And
this
then
thing.
doesn't
that was
matter
super ridiculous
xn
in the area.
squared equals x0 squared times x1 squared to xn squared. So we're trying to prove this.
All right. So what are the x's? They're the lengths.
So yes, so
They're,
they're all lengths.
oh, so they're all right triangles, and then
Yeah.
one is another height, is it?
Yes, it's every height. This one.
And you want to prove that the sum of the squares is equal to the product of the squares. Yeah.
But product of lengths don't actually like. What?
All right, that's good.
Okay, so well, I haven't fully solved the problem yet, but basically it's a proof by induction. So we have to try and prove the base case first, where n equals to 1. So there's only 2 terms.
Mm-hmm.
So we're trying to induction by induction. So basically, if you can see, let's just see for this triangle, right? This is 1, this is x of x1. So that's just going to be roots of x1 squared minus 1. And that is just root of x0 squared minus 1. And all of this is equal to root. Is that how I did it?
Oh, I remember how I did this now.
And all of this is
Just
equal
area
to
equals area.
the root of x, and
One-
this,
one times
and now it's easy to see that root of x0 squared minus 1 plus the root of x1 squared minus 1 is equal to root of x0 squared plus x1 squared. So squaring both sides, you get x0 squared plus x1 squared equals to x0 squared plus x1 squared minus 2. And then minus, and then plus 2 root, you can multiply them together, x0 squared, x1 squared, minus x0 squared, minus x1 squared, plus 1.
Wait, so
Basically squaring.
But what are you saying? So you're saying those two add up to. Oh yeah, okay. That's Pythagoras, yeah, and then
Yeah. And then
and then
these
you square
cancel
both
out.
sides.
So you get 2 equals to 2 times of root x0 squared, x1 squared minus x0 squared, x1 squared plus 1. And then of course these cancel out, and then you can take the square root out as well. So it's just 1 equals to x0 squared, x1 squared minus x0 squared minus x1 squared plus 1. These cancel out as well, and you bring one side, and that's equals x. That means x0 squared plus x1 squared equals x0 squared x1 squared as required.
Also, I guess what does it ask to prove for all n?
For all n.
Greater
Yes.
than 1 or 0?
It doesn't matter. It's just any non-negative integer. For 0, it obviously works.
Yeah, 0 could have been the base. Okay.
So you could have just skipped all this.
Well, no, I mean, you're gonna say, yeah, well, if this is your only idea.
Wait, you could have skipped all of this?
No. I mean, the induction step is gonna look like this.
I mean, like, because if you choose this as base case, well, then this is going to be, the first jump is going to be very different from the others. So I guess that's a bit of a problem.
Okay, or do you know, can you prove the induction step with this method or like this?
What can I prove the induction step?
Can you prove the induction step?
I think we can just rub this out or something. What should I rub out now?
Oh, you can rub it over. I reckon.
All of this?
Well, you
Oh,
probably
it's
keep the
still 3
diameter.
views.
Okay.
That makes 1. Just kidding. It's 2.
So we don't need really much of this.
Because I just used similar angle with the one and that side.
Yeah.
Yeah, and then that ended up working.
All the triangles are right.
So is it because he's doing that way, it's gonna not be easy to get the next step, or
Might be.
It's very hard to get the next step. I don't know how to get the next step, but I'll have a try anyways. So if you have 1, x0, x1, x2. We now try and just prove everything. Let's put everything instead we assume xk, say equals something called zk.
Okay.
Or maybe we equal to zk squared. So we can call this z1. We can call this z2.
I mean, that's a claim.
Huh?
Yeah, I mean,
Well, because of this.
yeah, I mean, you're claiming that this number is now equal to the hypotenuses, right?
Yeah. For each hypotenuse.
Yeah.
Then that means I can't use it as a variable in the proof.
Well, you can because I mean, you don't have to. You don't have to prove the original statement by induction. You can prove a stronger statement that involves this zk, right?
What do you mean a stronger statement? I don't even understand.
Because you're also claiming that this expression is equal to the hypotenuse squared, right?
Huh?
Like you're not just proving that they're equal anymore. You're actually also proving that it's equal to the hypotenuse of the triangle squared.
Oh, okay.
So you can prove
but-
that statement by induction, right?
Yes, because zk squared, because each of these, this one plus this one is just squared, is just going to equal this one squared. And then if you add that one squared, then it's equal to this one squared. These three. Wait, is it? I think so, because each of them can be used for the next one. So can we just induct that instead of the original question?
Yeah, you can induct that on top of the original question, yeah.
So I just don't know what do I actually have to do. Like, do I just prove this statement?
So you're proving the same thing that you wrote there, but with k plus 1 instead of k.
Oh, okay. So basically what I'm trying to prove now is basically zk
Plus 1
plus 1
squared.
is equal to no, I
You
think
following?
no, I think this is better. If we prove that x 0 how will I structure this? I'm still having the plus x1 squared to xk plus 1 squared is equal to zk plus 1.
No, and it's equal to the product of those squared, yeah?
Yeah, and it's equal. So basically we're proving two different things. And x0, x1, x2, xk plus 1 also equals to z squared k plus 1.
Yeah, okay, sure.
But the problem is I don't know how to prove that. Wait, like that?
Yeah, I mean, look, so there's a natural way to proceed, yeah?
Yeah.
So, like, the sum of the first k plus 1
Yes,
squared.
this is easy to prove. This one's easy to prove. Because you just say for any xk, for any zk here, then if you have this must also be x.
You're not listening to what I'm saying,
What?
okay? There's a natural first step. You're going to add up the first k terms and then plus the k plus 1 term, right?
Oh, okay. So are you trying to say this?
No, don't erase it.
Huh?
So you're adding up the first k squares, right? And you can use the hypothesis to say that that's the product of the first.
Oh, so are you
And
saying
it's also equal to the zk squared, right?
that I should write
Wait, what's it?
z?
He's labeled z as the hypotenuse of each of those triangles.
So are you trying to say zk plus xk plus 1 squared is equal to prove that
Squared.
squared is equal to the z k xh xk plus 1 squared.
Yeah.
So you have to prove this. prove.
Yeah, and that's exactly the first step that you proved, right?
Also, I did do it correctly.
No, you had the idea, you didn't
Yeah.
set it up correctly. Yeah.
Yeah.
So that process you went to show that n equals 1 worked, right?
Oh, that
It's
should
exactly
be
the
the
same
use.
process you used to do the induction step.
Oh, so I accidentally actually did it twice.
Well, you did it once there and you never did it again.
Yeah. So
But
that's
that is the induction.
Yeah.
Doing it
So if you just do it with the labeling k and k plus 1, you would have got it, yeah? Does that make sense? Because now
oh,
you only have
okay.
2 terms and you're just really working on that last triangle. And instead of x0 and x1, you have zk. and
XK. So
k
we
plus
just
1.
the same process that I did for the base. So basically, what I could have done is have a base case of x0.
Yeah,
which
so
we-
it's, I mean, the advantage now is that it's like, okay, so yeah, you can do the base case x0, yeah?
Yeah.
But you also change the statement, right? You also change, not only is those two equal, they're also equal to the hypotenuse squared each time.
Yes.
Yeah? So that helps you because you can prove the base case just as easily, basically.
Yeah.
But the induction hypothesis is stronger now, right?
Yes.
So then you can use that to get to the
prove
induction
it.
step. Yeah.
So if we induct the same process with this, except now it's at the last triangle.
Yeah.
So we do the same. Now it's at the last triangle with 0 and 1 being replaced by k minus 1 and k. So if we follow that up, we get the last solution of xk squared xk plus xk minus 1 squared is equal to xk squared plus xk minus 1.
No.
What?
Your xk there is zk, okay?
Okay, I don't understand. The ZK is for
So the zk is this.
Oh,
So
okay.
if you draw your diagram clearly, so look, the zk goes here, right? And then xk plus 1 goes there.
Oh, okay. Sorry. So this is, I got confused. This is x0, but this is z1.
Yeah, maybe the labeling is different.
Yeah, the labeling is very, very confusing. Probably should have labeled them better.
Alright, can I show you something? Oh.
Yeah. Okay.
There is one other way that comes in handy, especially when you have these
Wow.
when you have these right angles, okay?
Really?
So there's one idea that's pretty good when you have right angles. It seems to come up
Oh, why
enough.
not leaving?
So you have
Just
this
like nothing in here.
x0, x1. You can call this, I guess, z1 if you want. z2.
Right.
So these are all 1, right? This is x2. So, kind of annoying. Where'd it go?
Here's the first.
Yeah, so,
Oh, you have to set to.
huh? So one way to avoid all those square roots, right?
Yeah.
Is, can you see that the area of the triangle, these are right angles, right? These are given to you as right angles. Yeah?
Yeah.
So the area of this triangle, yeah, is x0, x1. 2 times the area of the triangle is x0, x1, right? And then 2 times the area of the triangle is also 1 times z1, yeah? See that?
Oh, okay. So yeah, that's why I was like getting stuff by all the products. I didn't know how to use the area properly.
So that would have been quick.
Like, yeah, because like if you use the area, the products is no problem.
Yeah, so to prove it, I guess you state the claim, stronger claim, right? You say that x0 squared plus x1 squared plus
So when you
xn
say
squared
stronger claim, it
equals
means a claim that
x0.
automatically proves more than.
Yeah, so not only is it equal, these two are equal, but they're both equal to the hypotenuse squared.
Yes.
Okay?
It's easy
Yeah,
to
and
prove
I
the
guess-
first statement.
Maybe you could just say z0, and then define z0 to equal x0 or something.
Oh, okay.
Or you can just start it at n equals 1, but either way, right?
That
So
makes
maybe-
a lot more sense now.
So if you do n equals 1, right? Then you have x0 squared plus x1 squared equals z1 squared. That's Pythagoras, right? Yeah.
Oh, let's keep it like infinite.
And z1 squared is equal to x0 squared times x1 squared. So that's the first
Oh, okay,
case
so you
one.
use both the
So-
Pythagoras and the area.
Wait, so you prove that this is you let that be z squared.
Hmm?
So cause that's squared, that plus that squared is that squared and that's squared.
Yes. Yes, so you let
Yeah.
that equal z squared in.
And then for that,
And then for the second part, you just
So then
prove
you
the area.
assume n equals k is true, right? So
Yes.
that's x0 squared plus xk squared equals zk squared equals x0 up to xk squared, right?
but this is kind of weird because like if you don't this keeps on reducing every time. So when it goes to infinity, it's actually approaching 0.
But why does it matter? Why does that matter?
Cause
We're
I-
not.
Because then you're trying to find xn, right? And since xn is like
Uh-huh.
infinity, then shouldn't that be 0? And so it's weird.
It's because you're adding more stuff, it shouldn't be true.
Because then that if that's because this every triangle, this is getting shorter and this is getting longer, and then this is getting shorter, and so when it approaches infinity, it should be 0.
What approaches 0? What approaches 0?
Or the
X.
is that what?
No, this gets shorter every time.
Oh, okay.
So extension.
Oh, he means this part.
Not that part. That part.
No, that stays at 1 every time.
No, not that one. That one. X1.
Oh, that is kind of interesting. Okay. Anyway, let's finish this off, yeah? So you want to prove it's
so
true if n equals k
if you
plus 1.
use the area, that makes it a lot easier.
So you need to show that this of the k plus 1 squared is equal to zk plus 1 squared, right? Is equal to x0 k plus 1.
So of course, this is easy to show.
Yeah, but so we have x0. So the induction hypothesis gives you that this thing here
Is equal to
is just it's
zk
not, it's zk squared
plus xk plus 1 squared.
plus xk
Yes, and
plus
that's
1.
obviously true by Pythagoras.
So this is zk plus 1 squared by Pythagoras, right?
Yes. And
Yeah.
now then you also now you prove this part.
And that's the area.
Yeah,
Which
now we
is-
can do the area thing, right? So yeah, so this is the square of twice the area, yeah?
Yes.
So this is the square of twice the area, which is zk times xk
xk.
squared, yeah? Because that's square of twice the area, yeah? So it's this. Oh, maybe it's xk plus 1.
It's
Yeah?
xk plus 1, yeah.
Yeah? So that times that is the area, yeah?
This times what? That times
Yeah, and this by definition here is just the product up to k, right?
Yes. Yes, by definition.
Okay, and that's done by induction.
Yes.
Yeah.
I think like it's like an even faster way maybe. It's like-
Fasterer.
like-
Faster than instant.
Faster than split
it's
second
pretty
card.
much instead, I think.
Mana split, mana tap
might
available.
be similar to like what you did, but
Tap that mana, boys.
You have so you have this triangle is similar to this triangle here, and so this is like hypotenuse on the short side. So xo on 1, have this as z1, yep, is equal to z1 on x1. So then z1 just equals
X1.
x0 x1.
Yeah.
So then
So that's twice the area.
yes, which is like and so if you square that, that's just the hypotenuse, which is which is equal to x squared plus x1 squared. And then so once you do that, it's really easy to induct this. I think
It's the same thing.
it's like easier to induct than this.
Wait, what? So X.
I think it's easier to induct than this thing. But yeah, it is.
I mean, it's just this in relation here instead of this relation.
Yeah. Yeah, I think this is like easier to conduct because like let's say
Oh, what's the statement then? So the statement is you're labeling all the z's as hypotenuses.
yeah, so
And then it's this. It's the same statement.
yeah, this thing is just the square of the hypotenuse.
Mm.
Yeah.
Yeah.
Because for like to induct this, it's just that, and then we know that like because we just apply the single triangle again, so we just apply that like so with like this thing, and then on one is equal to this. So then the new one is just that multiplied, and this side you just apply Pythagoras.
Yeah, that's what we did.
Yes, but like I feel like it seems a bit longer than like.
No, I just wrote out the assumption.
Okay, yeah.
No, it's absolutely identical.
Use similar triangles of the area.
Similar triangles.
But the equation you get is identical.
Okay, yeah.
So use the area.
Can you do the
Okay, yeah.
explain it? Well, what question was it? It was
Question 10.
question 10, 2008. I can't remember. It was there was the one with the triangle and the altitudes.
Oh, that one. Oh, yeah.
Did you try that one?
Yeah, I did.
I didn't write down what year it was. It's in the notes as well.
Group the rhombus.
Oh yeah, you could show us the rhombus. I just don't know where it was from.
So what's this problem?
Yeah, this one. I think it's this problem. Yeah.
So you're given a triangle.
So have a seat, have a seat.
A
CD.
Yep. A D C. So A and DC is like 65,
Yes.
and the altitude.
That is 32.
He said he likes it and he subbed.
What?
You have to move the laptop.
Sure. So we got one like.
And then
We got one like. I can't join. So we can.
No, can we not have people who are here join the stream? You're gonna lag it.
And
We're getting more likes.
so and this is 63.
Like you're using my data to connect to my live stream. And then like
So
so pay attention.
You have 2 likes now. 3 likes.
Oh, thank you.
You have 3 likes. And that wasn't even me. Damn.
so you have a triangle
You're gonna become a YouTube
ABC, and
It's like
so DC is
you
65.
gotta listen to
The altitudes DB is 33, and the altitude CE is 63.
Wow, realistic drawing.
And then basically it asks that to prove that AE and AB cannot both be integers.
They cannot both be integers.
not both be integers.
And then it says, can you find them?
Can't find this.
Why does it say, can you find them?
Michael,
It says, can you find them?
That was like the investigation.
Like,
So first, like we just apply some Pythagoras here. So 65 squared is and minus 63 squared.
Yeah, I did the same thing to start, so
Yeah,
I'm not gonna go through that again.
Okay, so
It's
what we
2
can do here is we can just
2 times 1 to
okay, yeah. So 2 times 128.
which is 2 to the power of 5. I think. No, 4.
16 squared.
I mean, 2 to the power of 8.
Okay, it's difference of 2
squared.
squares, which equals 16 squared, right? So that means D we know is 16. So for that it's 65 squared minus 33 squared is equal to 32 times which no, sorry, 32 times 9, yep. Which is just
2 times 2 power 5
to the
2 times 7.
3 times 7 all squared. So then this is 56.
56.
So now we can set this as x and y.
Oh yes. So we have identical solutions somehow.
So here, if you just apply Pythagoras to these triangles, we have x squared plus 33 squared is equal to y squared plus 32y plus 256. And here we have y squared plus x squared is equal to
Oh.
and now what we can do is see here, if we just add both of these sides here, then we can cancel out these.
Sure.
X.
Yep.
X.
So
And I guess you got to cancel out one of the equal signs.
yeah. So 33 squared
Plus plus
3 squared
equals equals.
minus 16 squared minus 50 squared is equal
Wait, how does cancel out equal signs
33
actually work?
y.
Maybe you just make them extend next to each other.
Then you just put the two square next to the C.
Yep. So now we don't actually have to find out what this is. We just kind of so we link these two. So we go.
If we don't find it, how do we know it exists? No, sorry.
What's the laugh?
Wow, that just made one like disappear.
You'll laugh.
Yes.
Really?
Yeah, it did.
That is 4 people joined. Another person just joined.
You lost a like for laughing?
Yes.
Which is equal to 7 times. Which is equal to 49 times. I don't know.
Someone unliked. Another person unliked because I laughed again.
Oh, okay. Can you stop laughing then?
That is zero
No,
likes.
there's zero.
But this 4 people, another person joined. Then it's 0 x. Wait, this is equal to 7 times 17.
See, now there's no likes.
7 times
Because I
17.
laughed too
so
much.
these two is just 2.
Wow.
Oh,
We're not
I
like
guess you're not going to be a YouTube star.
Yeah, so then 17
Oh, there's one like that. 49.
Oh,
2 times 2. Yeah.
plus
such flippant people.
times
Whimsical.
17.
17.
And you get 2 times.
So you don't have to actually work out all of the
Seven
squares.
to 17 times
49 is 16
2 y.
plus 7x. Cancel and then you
So
find
now
this
we can
is
cancel this
8.
to an 8. And we can see that the
This
17 times 49 is obviously going to be odd. And then
Yes.
8, since 8 times whatever is going to definitely going to be
Even.
even, then these cannot be equal if y and x are integers.
Yeah, integers.
Yes. Yes. Now another person liked because he solved the problem.
Wait, so
The third person's not liking. You do it different.
It is.
Like now.
so it was the
well,
left hand side. Oh, yeah. So basically, you have the one side is even, one side is odd.
Yep.
Okay, cool.
What did you do?
Can't be
What did you do?
Oh, I might. This is in line with the solution. This was what the solution was.
What did you do?
So okay, I have this because I was in the mode of the other question, which is find areas. Don't you remember? Like this seems to come up all the time. Okay, but it doesn't won't work out as quickly. So can I erase this now?
Yeah.
Yeah. So I mean, see, the thing is, like, your problem solving will depend on your context, right? In our class, you might think of different things than if you were by yourself or in other class. Yeah. So one of the things we were thinking about, since we saw those altitude things so many times, right? You could kind of do like the area of this triangle is equal
But wait,
to
is this a
16.
rectangle? The XY, is that a rectangle? No, it's not. Is that a rectangle?
No. This is- So I mean, the area of the triangle can be found two ways, right?
Yeah.
So you can use either altitude, and let's find twice the area of the rectangle, the triangle, right?
Yep.
Is times 63, is it?
Where yeah, 63.
63
It's equal to x plus 56
times 33, right? Okay. So usually this wouldn't be so easy to proceed from here, but we did that equation before, right? I mean,
Yes.
It's just a linear equation.
Diophantine equation.
Yeah. We can cancel out 3 if you want. Sorry.
21. 11.
Yeah.
11 times 6. You meant to extend the left side.
Alright,
somewhere.
guys. No random noise.
You meant to extend this side.
Yeah. 16 times 21. I didn't actually completely do this, so let's see how it works. Yeah, maybe we can put this all on the same side now.
It's about area. So when you see a problem, when you see any geometry problem, think about length, area, and angles. Correct?
Yeah, I guess this is more of a geometric approach, right?
Yes.
Yeah. But I feel like we've been just beaten over the head by that kind of thing so many times that
Yeah, the altitude and
it kind of comes out at you. Okay, so 21y minus 11
especially me.
equals, so 56 times
Two
20
likes.
times 11 minus
Still
16
two
times
likes.
21.
You just have parallel to and you can find your unit pretty sure.
Yeah, I mean, what's this number here?
Why?
I think this. What's this number? What are you laughing at? There's a factor of 4 here, right?
Yep.
And that's 14.
They'll probably be staying.
You just laughed. Oh, it dropped to 1 like.
Guys, you guys are so annoying. You guys, maturity.
It's 1 like now.
154 minus 84, right?
Yeah.
So this is 4 times 70.
Yep.
Remember, we learned how to solve these equations. Remember?
Oh yeah, 21. Well,
Remember how to solve them?
Yep.
well, there isn't an obvious contradiction like last time.
Yeah. So it wasn't as obvious, but
Yeah.
but we were like, but this is sort of natural, and if we knew the theory behind that equation, it's routine,
And now,
and we do, right?
Well,
So these two both have GCD 1, yeah.
Yes.
so you mean
So you're just basically solving 20y1 minus 11x equals 1, yeah?
Yes.
But that's kind of easy to do because you just like, this is just
2.
1 and minus
1.
2,
That's
right?
minus 2.
Yeah?
2.
Let's see. And then,
We're trying to do that.
oh, this should be, is this minus 1?
So you got,
No, it's,
So-
no, that one's x is
This is
2.
minus 1.
Yeah,
X is-
yeah,
wait, so you
Yeah,
got,
yeah.
This is right, yeah?
wait,
Well,
wait,
then why do you put 2 minus that?
And then
wait,
Huh?
so you got that is equal to that, right? The 4 times 70, right?
Yeah.
And then,
And then what are you trying to do then? Wait,
you multiply everything by 2.
Yes, and once you got the solutions, so let's write it in the form that we like did, right?
Yeah.
So it was like, so let's do 11x. Oh, I shouldn't have changed the order. Equals 1. Yeah, we know how to solve this because the GCD is 1. That's 1 here. But we can also eyeball it here, so that saves us that first step, right? So this is 2.
Negative 1.
Yeah. So x is the negative of what it was before. And then plus 21 negative 1 equals 1. Yeah?
Yep.
And then to get it into the 4 times 70, just times them both by 4 times 70. So like 11 times 2 times 4 times 70 plus 21 times minus 4 times 70 equals 4 times 70, right?
Yeah.
Just times everything by 4 times 70.
Oh, right, and then
And
to
then,
make that non-negative, you have to do
yeah, so you want to make this one negative because upwards is negative of the original.
yeah.
And then you want to make this one positive, yeah?
Yep.
So the only other solutions that you get by adding multiples of 11 to this, and subtracting the same multiple of 21 from that.
Yeah.
Does that make sense?
Yeah.
Can't you move
'Cause they're
the
rel-
11
'cause
to
they're
the
rel-
other side and then try to find the answer between 21 and 11 and that 4 times 70. And then so
Oh, are you saying there's a contradiction already?
yeah.
Plus.
Don't think there's a contradiction already. If you do
Yeah,
that.
like what x might be a modulo of 7.
Yeah.
Yeah, x could be a multiple of 7.
But do you have to do it?
Oh, wait, no, but then if x is
Yeah.
a multiple of 7, then
So-
okay,
yeah.
fine.
So can you see like the point is if you take this equation like mod 11, right?
Yeah.
Then like 21 times y
Yes.
has to equal 470. Like 4 times 70 mod
Yeah.
11. So like for that to not change mod 11, you basically have to be adding multiples of it.
Yeah.
Okay. So that's why if you add multiples of 11 and subtract multiples of
Did you
21
pass?
here, you get all this solution.
Yeah.
So you got to basically subtract enough 21 so that this is negative, right? And then you got to add enough 11 so that that's positive.
But that's
Yeah.
clearly like
So minus 4 times 70 plus
I think it's what it's
11. Okay. Needs
I
to be
think that's
positive,
enough.
right? And then we need 2 times
Please
4
ignore
times
me.
70 minus
Yes, that's
21. Okay.
So now to remove the people's eyesight.
Needs to be negative. Yeah.
See, what happens if there's people with glasses out there?
Is it quite?
It doesn't do anything because it's not a
I think it
does.
we might only end up with just one or no case.
doesn't actually
that
do
work.
anything. What is it?
So what is
That's just
how
so
do you
much
get
stuff.
how many 11s do you need? So this is 280, right?
Yeah, so you need like 25,
25.
26, 11.
26.
2611. So what's 2611?
280.
So K is at least 26, right?
Yeah,
Yeah.
that's
And then what's this? This is twice that, right? So 560 minus so 21 times 26.
Yeah,
is
that's
546.
yep. So I have to.
So that's the only one that works then, right?
yes.
26. If it's any bigger than 26, it won't work.
Wait, what,
So 26 is just under. Wait.
it has to be over 26. It has to be over 26.
Oh, we want to make it negative, yeah.
It's what? It has to be over 26. Yes.
So it has to be 27. Wait, I didn't quite check this out. Does this not work?
No, I don't
I
think.
think
it
like
will.
maybe like once you get over, you can like have the triangle.
Oh, you just
Oh
commented.
yeah, that's right. Okay, so because you know
Why is he
it's like one of these sides.
He just commented.
Yeah,
He said
that's
he said X is 7 and Y is 17.
Oh.
Does that work?
No, it doesn't.
Yeah.
Yeah.
Oh, okay. So then
30
K
minutes
has to
left.
be greater than or equal to 27. Is that what you're saying?
Yep.
And so then
So what was K again?
yeah, did you already say the numbers? So then 46 minus another 21
Yes.
minus 567.
567.
So that's 7. So X, did you say 7 and 17?
Yes.
Yeah, okay. That's what he said. Good. Yeah, so 7.
17.
Do we believe it? Oh, let's just say 7, 17. And then the next one will be,
But wait, isn't that a solution? No, it isn't.
oh, I mean, it could be, but then I think it might not satisfy
Yeah,
the Pythagoras, or it might not satisfy the triangles.
Yeah, because like clearly the Pythagoras is wrong, so you can't do that.
Yeah, I mean, there can't be infinitely many because, yeah, as Haibing said, once you
Yes.
get over like 60 or something,
Yeah.
it's going to have trouble with the
So
triangle.
that there is a solution. Can't say there's not a solution, but none of them work for the Pythag. So I think the other way is still better because you take into account Pythag first before you do this.
Yeah. So if it's 17 and 30, it's 23. So, yeah.
So it doesn't work or it does work?
I think it will work, but it just will take a lot longer than
Yes, it'll just take.
but still all routine. Yeah, there's no thinking.
You know, like extraneous spark of genius required.
So if X is 7 and Y 17, it does work or it doesn't work? Because if it does work, then the whole thing.
No,
Yeah,
because like
obviously they
it-
shouldn't work. Right?
obviously it doesn't work if you put y equals 17, x equals 7. That's already 63.
Like, and for example, like if y is 7, that's 23,
Yeah.
right? 23 squared is meant to equals 17 squared plus
Oh,
33 squared.
Doesn't
Yeah.
work.
Yeah, like so this can't be 23 because that's the hypotenuse, isn't it, of this triangle?
So he's wrong?
Yeah, 7. No. I mean, he's
I mean,
not
he's
wrong
right
because
for
there's
the,
a
like,
solution to this
There
equation.
is no solution for the.
And then the next one
diavantic
is
equation.
like another 21.
Diavantic
so it's like
equation that
28,
also matches.
28. Yeah.
Yes. And of course
Then
that
it'd be, you know, like
50.
yeah.
Can you?
It'll be 49.
Yeah, 49,
49, 35. No. 30.
39, yeah.
And that obviously also can't work.
Yeah, I mean, it was a question 10, and like if you don't come up with the idea that they're thinking of, and you have this one.
Don't take
No.
a bit of thinking.
Yeah, but I guess what I'm really trying to show you is that stuff that we do can lead to the
Yes.
answer, and this idea of heights has come up so many times.
What's the last thing like before the exam? Because like it's our last session, so
Wait, aren't you coming on Wednesday?
no. Because there's no point.
Why?
Hmm.
Wednesday's a cram day where you cram everything you possibly
No,
can.
Wednesday the day sleep.
Yes, today I'll catch up with some sleep, like sleep at 6.
But you're gonna sleep at 6?
Yeah, I guess so. I guess it's
That's
not
a
it's not a
hypothetical
great
thing.
use of time to finish this off as it
Yes.
is because we've gotten enough out of it.
Yeah.
But so did you want to go through another question?
Yeah.
So
what
can you go
about
through the
these?
K?
What's
Huh?
these?
If there's K.
Oh, if this K, so you want to go?
It says K4.
Oh, if it will take ages.
Oh,
Can we
right.
go through
We can
one
just
of the-
derive it from the one we got before. I think what was the time before? It was like
So it's this kind of
Yeah.
and you had some
like since one of them had like was like a multiple of 8, the other one was
Yeah.
didn't have 8, so you just had to put an 8 in front of one. So if you have K squared was 8, I'm pretty sure this works.
Oh, okay.
Because
So
one
there
side
was
has a K squared and then
yeah. So the investigation was that it was a K.
Yeah.
And I guess you need the K to make up for the multiple you left. Is that what you're saying?
yeah.
All right.
So this geometry.
Excellent.
Do you know my sheet?
Did you have any other questions you wanted to bring up?
What are these questions?
Oh, so 1 and 2 I only wrote up there because I didn't have any answers written down somewhere. But 9 I didn't have any written down because I didn't write it down last time. Yeah, that's heaps of paper. Do you want to do 2017 question 9?
Yeah. What was that?
Oh, it's like a circle and you have like 10 points.
Oh yeah, I did.
Which way?
Wait, what? Where's question 9?
You like and subscribe.
Oh, nice.
Yeah, I guess like here, y is like this little part of this hypotenuse.
Yeah.
It has to be. Yeah, so y has to be smaller than 56, I guess, as well. Oh no, 56 plus x.
So if you put a K,
So there was another thing I was thinking of, was like, I guess they didn't draw the diagram for you. So how do you know the altitudes come this way? And
oh
not-
yeah, I was gonna think about that.
yeah.
But I think my thing's still like kind of quite similar if you do that.
So what problem are we doing now?
So, I mean, 2017 question 9 was suggested by you. Have you tried it?
Mommy?
Yes.
Okay, where is it there? Forgot about it. Wait. Did I say? And also, where is it? Can't find it. Wait, is the 2017 paper here?
Yes. Did we already go through this at some point?
Which one?
This question?
Which?
I don't think so.
I
So the
didn't.
question was
Wait, shouldn't it
I didn't suggest.
so the question was you have 10 points, P1, P2, P10, right? And they're equally spaced around a
K squared on
circle.
one side and K on the other side.
Yeah.
Throw this
And
out.
then
Put this in.
once so if
When
this is one side
And
has
then
a
on the
factor of K, the other one doesn't. It's a set K8.
So they're equally spaced around. This is like
Yes.
2017, question 9.
Yeah.
Equally spaced around a circle, right?
Yep.
7, 8, 9, 10. Yeah.
Yeah, so first.
And they are connected in separate pairs by 5 line segments. So you pair them
Oh,
up
so there's
somehow,
5 pairs.
Yes, so first.
And
How
the
many
only
ways
one-
can such line segments be drawn so that only one pair of line segments intersect? So like if you draw this, then these other ones can't go across. They can't pair across the line, right?
So you realize that.
I mean, so is there only one intersect? Is that what it says?
Yeah.
Okay, so once you draw in these intersections, then these other bits are stuck in their little parts, yeah?
Well, obviously, we're looking at the 4 points that, the 2 lines that intersect first. And of course, one
And
thing.
so how many such line segments can be drawn?
So
One thing that can be ruled out immediately is you have a cross like here, and then you have another cross because that point can't join anyway.
wait, so you first realize that if you
So that means the two lines must be adjacent to each other. Like if you have so if you have the first line, say any first line here. So let's draw the 2 lines that this has to be 2 lines that intersect, right? So say you draw a first line. This will be one of the 2 lines that intersect, and there's 4 points on each side.
This is not systematic enough.
I mean, to find the systematic way takes like a bit of time.
Yeah, I know. It takes a bit of exploration.
Yeah, so can you see like the question's kind of like you're gonna get some answer. The number's probably less than 100 or something, right? Like it's
Yeah.
gonna be not that big, and it's probably not gonna be hard to get some of them, right? So the whole point of this question is not to miss the cases.
Yeah.
Yeah, and to count the cases with the right multiplicity.
Right, so if you realize that this thing has to split into an odd number of things on each side, because otherwise you're not gonna have one that crosses, because the two you either
So if you have a line here, then you can't cross it with another one.
You sleep at 9
so
p.m.
you realize that the line has
Yeah,
to
some
split.
people sleep, Leo.
I sleep at like 1. And that's
The line has
average.
to split circles.
Then you wake up at 1.
odd numbers.
No, I wake up at
Otherwise,
4.
if it's not odd, then
It's a full 3
they'll
hours.
either all connect to each other or more than one will cross the line.
Second.
So the line has to split the circle into all numbers. Otherwise, if it's even, then the like dots will connect to each other, or the more than one will connect to the other side and cross it.
Oh, okay.
Wait, what?
Even.
If there's an even number of dots, just say I connect these two.
Yeah.
Yeah.
These will have to connect to each other,
Why?
or two. You need two dots for a line.
Can't you cross it?
And then you get 3 dots.
Yes, you have one left over.
Yes.
Let's cross that over. Yeah, you have 3 dots left.
So you can't do
Yeah,
anything
need
else.
2 dots for a line.
So you can't have anything with one.
You can't have anything with the even.
Okay, so the first line has to divide the circle into.
Yes.
Okay,
So
so
you're
you
using that unique.
then you realize there's only like a few cases because this case is also equal to like.
What do
this-
rotations and
this
reflections
case.
count?
They label the points so
label,
they do
yeah.
count. It's equal to this case. It's just flipped over. Okay. So we just multiply the thing. So it's this case or this line. It's either one of the 2 lines.
Intersection as in the middle, or can it be in like one point as well? So that's one intersection.
Yeah, that depends.
Wait, what's
Like if you cross these 2, then that intersection
yeah, I
counts.
said if that and that go to the same point.
That doesn't count.
You can't,
can't
have
have
2
two-
points that
You
go to
can't
the same
have
point.
a line
They're
that
in
connects.
5 distinct pairs.
They're like 5 this thing that
Yeah.
a
10
line
points
joins 2 points.
Yeah, the 10 points are in 5 distinct pairs.
So you find a maximum, right?
You have to find everything.
So,
So
okay,
you
it's
join
five.
this
For example, you
for,
can join here, here, and then the rest can go.
Yeah, so that one.
for a point like this.
Yeah.
You can join this to here or you can join this to there. And that's the same.
But you can't join this to that because or else this one has no other.
Yeah,
So-
so I guess something to watch out for is like if you do join it here now, you have the sort of asymmetry between the two.
Oh, I didn't see
So if you're
A
counting
systematic way to count it is that if the first line goes here, right? The first line goes here, then this point has 1, 2, and 3.
that. Okay, so we realize that this line can't go to one that's,
Can't go to here, can't go to here.
one that's even number away because then the same problem still arises.
So you can only have these 4 points.
Oh, okay. Yeah.
So you only have this
Four.
one, that's
Yes, 4 points.
then I don't see this one. This one is equal to that because we just rotate it.
Yes.
Yeah, so for this case, number of things we put is up to 6. It's 5 actually. I'll show the for 5 possibilities. 1, 2, 3, 4, 5, 6. First you have these 2 connected up, or these 3 connected up like that. Then you have these connected up like that. That's 2 cases with this thing there. And then you have these. Oh wait. These and you have these. And then you have one of these.
Yeah, but you have enough information here to try this yourself, right?
Yes.
Because it's we don't have to show it all to him.
Yes. But we don't have
He did this like a month ago. 2 months ago.
but the thing is I have like no time.
Yeah.
Oh yeah, yeah.
Just
So,
seeing the solution on your
It's a bit like pointless.
That's one. This, that's another one. Then this, that's like 3 already. Then you have this, and the other way around. That's 5.
Then you can rotate each 10.
As if Kavan was here, because he actually did this one as well. We could get him to do something.
Wait, is Khan watching?
Oh, I don't think so.
Ben is watching. There's 3 people.
It's now 2 people.
There's 2 people.
So
I swear Khan's watching.
that's the case for this one to that. Then there's this one to that.
I think if Kavan was watching, he would say something in the chat.
Khan, if you're here, say something.
cross off here.
I think one important observation
These
Is that
cells connect and these
is that there's only one way for
Ron,
lines
if you're
to
here,
not
you have
connect.
to say something.
Self-destruction.
these are two
I think
ways to connect.
One important observation is that there's only one way for a certain set of points to not cross at all.
And if there's only two ways to connect for this, so 2 times 2, which is 9.
Wait,
And that's 4 in total.
you can do that and that.
4
and
plus
that,
5,
and that.
which is equal to 9. What would the case with only one?
Yeah. So once you got the two that intersect, then these just have to all these ways of going. with
Oh,
each other,
so-
yeah.
And there's so many
So
different
what I said was
possibilities.
that for any set of points, there's only one way for excluding reflections and rotations. There's only one way of things to not connect at all, to not cross at all.
So how many are there in total?
10.
Then you consider this one.
Yeah, well, I mean, not crossing at all is not the negation of crossing once, right? It could also cross twice, 3 times. Like, crossing exactly once is not the negation of crossing no times.
Once you cross one pair, then the rest only has one combination.
Once you cross one pair, the rest are very limited, but there's tons of combinations still. Like, they could loop over each other, or could they just be separate, you know?
This can't be the middle one. So this is the middle one. These cross through the middle.
Yeah.
So it has to be for this one. So this one goes there, this one goes there. This one goes there, this one goes
This
there.
is mostly case bashing line.
And yeah.
No, because I think it's not obvious what the cases are, yeah?
Yeah.
The case bashing part is not what's
Difficult.
interesting about difficult about this
It's
problem.
about how many ways in the first pair of lines
Okay,
cross.
you just need to find every single possibility.
No, but you don't know the repeats of the not
As
repeats
long
of
as
the
the
rotations of the not rotation.
Yeah, so you
And
just gotta
you
be
multiply this
careful
by
if they
10.
repeat or not, right?
And you multiply this.
So yeah, so you might want to list like all the ones that look different and then see how many times they occur with the different labelings, right? But there's definitely something there, and the very important thing is to start to try and do something systematic, so you at least get all the different types.
How about we
Okay,
don't
so-
include rotation entirely? Is that gonna work?
Yeah, you can do that, but then you gotta add it in later and see what the see how many you get for each one when you label it.
So rotations are the hard bit, not the actual cases.
But didn't you guys have any other questions you want to go through? I only put this one up because you said you wanted to, but if no one wants to go through
Oh,
it,
okay. Then we'll put something else on.
oh, we'll put Sean did this like 2 months ago.
Oh,
We'll
I
put
did-
this.
I was
yeah,
in here.
Huh?
I wasn't here doing it.
You didn't?
Kavan did. Like,
Oh, so you just did the board just then?
no, I did this after.
Oh,
He
okay.
sent it in the question.
I think
Oh,
there's one way to do it to make sure you don't like
Okay.
accidentally recount stuff.
yeah.
Did anybody
There's
do
one of these
questions?
solutions, but I realized it and then made it.
Oh, mine did it 2 months ago.
So
During the
this
holidays,
one,
right? 'Cause
Yeah.
I wasn't there. I was just skiing.
instead of like thinking about like which way the like how they're gonna cross it or whatever, one way you can think about it is like if you have two lines that cross, right, say like this, it will always leave four distinct like quadrants, four distinct like portions of the circle, like after you that don't intersect each other because you already have one intersection. So with this, you
They're even.
and each part has to be even, right? Because otherwise they won't be able to connect like all the points.
Yeah, very good.
So the way you can like, there's only like a few ways to do this. So if you have four quadrants, and keep in mind that with four of these points being used up already, you only have six other like you have six. So there's actually 10 times of these. And there's 10 times of these. Like
There's only one type, one possible.
yeah, because there's only one and there's only one way of doing this because no matter how you do it, it's always going to be
Two
like
times
2, 2, 2, 0 in some order. And then for a 6, 0, 0, 0, it's same thing. There's going to be 10 times of these. We'll get to this part later. Well, so we can worry about that later. For this one, we have we actually have a few ways. So we have 4, 2, 0, 0, 4, 0, 2, 0, and 4, 0, 0, 2. So each of these can be so there are 3 ways in total, and each of these can be done 10 times, right? But since there's a 4, right? If you have 4 points, there's actually 2 ways of doing it. It's either this way or it's this way, right? So there's actually 2 ways of doing that. So it's 2 times this. So in total, with the 4 200s, there's 60 ways of doing this. So now we look at the 6000.
6 5 ways.
Yeah. So if we look at it, if we have 6 points, right? The way you can systematically do it is if we connect these two.
Yeah, there's
There's 2 ways to do this, right?
Yeah.
the other 2 then.
Now, if we connect this to somewhere else, this can't connect here, right? Because otherwise this will be odd. So we have to connect here. Then there's 1 way. And then finally, if this is connected here, right? We got another 2 ways of doing it.
So you're working out how many ways are there for 6 points to not cross.
So that's 6 points. So there's 2 2 1, right? That's 5 ways of doing this. So there's 5 times 10 here. So if we just add this up, it's just 10 plus 50 plus 60, which is 120. So there's 120 ways of doing it.
Wow, that's what I guessed in the first place.
This question 5 from last year was 120.
What? Yes.
Oh, this is the inside joke.
There's only 1 year now. What have you left?
Because people are going to sleep,
Excellent. Thank you.
which I will not be having any tonight. Because I have like 3
Should I get
hours.
0 hours sleep today? Maybe. If I just have like I just have to go sleep straight after.
Maybe that's not good.
You shouldn't.
How many times have I had 0 sleep?
Never. Probably once, maybe. Actually, I don't know. Probably never.
Once.
I stay out the day before.